So this is Smart Self-Checkup for Early Disease Prediction, paper ID number 22, and presented by me, Nur Ala Afika binti Muhammad Johari. For the abstract for this project, performing self-checkup using resources available on the internet is now a common practice among general public. However, with abundant health resources available, some information may not be reliable, thus implicating risks to those seeking health information. So in this paper, we propose a smart self-checkup mobile application that offers an early disease prediction to the public. The development of the application follows a methodology known as the process model for healthcare, which embeds the data mining predictive technique that extracts information from existing datasets in order to determine patterns and predict future outcomes. Medical expert testing proved that the rules are correctly generated, and this application is a very promising self-checkup for predicting early disease. The problem occurs when people now more prefer to just Google the symptoms without considering the sources from Google is suitable or not with the current environment. Next problem is not everyone understands the medical term, and lack of readily available medical sources for laymen may lead the misinterpretations of information regarding the diseases. The main objective for this project is first to identify the diseases and symptoms relationship based on the patient's history data, to propose a self-diagnosed prediction model by using process model for healthcare. Next is to develop a mobile application of self-checkup for early disease prediction. For the methodology, there are 7 steps that have been followed for completed this project. First is scope definition of the exercise. Second is selection of the reference guide. Third is identification of information source. Fourth, selection and preparation of healthcare information. Fifth, information adjustment and preliminary analysis. Sixth, selection and implementation of data mining experiment. Lastly is result validation and impact analysis. As for scope definition of the exercise, the first step allows to define the business problem to analyze. Several fundamental aspects must be clarified in this step. For this step, we throughout the understanding of the project objectives and requirement needed. This phase help to identify the issues in the present practice as well as the goals of an organization. The aim of this phase is to pinpoint the problem and business process, identify the scopes and objectives, define business analytic goals, and define the criteria of the exercise. In order to have better explanations for the requirement needed, we had conduct an interview session with the owner of the clinics. Next, selections of the reference guide. Because we are dealing with the medical data, so we decided to have a professional reference guide for this project. So for this project, we acquired assistance from the medical expert. In example, Dr. Wan Idayu binti Wan Suhaimi and Dr. Azizah binti Abbas, which are the owner of the clinics and the main reference when we are dealing with unfamiliar medical terms. Next, for the identification of information source, we gathered all data from the Azahra clinic. Then from the current data, we decided to only use specific attributes. It will be shown like this. So this is the data selection. Next step is selection and preparation of healthcare information. This is the crucial step which we need to have a support of medical expert to select the information that is highly relevant and related to solving the proposed problem for this project. Each type of disease shows different characteristics. Thus, it is important to us to have a proper data verification at early stage, as the wrong selection of data will jeopardize the final result. During this phase, a frequent meeting between us and the medical expert and lecturer will carry out in order to ensure that the data are suitable with the project. Next is information adjustment and preliminary analysis. This step consists of data transformation and data reduction process. This method of evaluation is essential to define the primary features of the information and to discover fresh variables appropriate to particular scenario. The initial data transformation took place on the symptoms. Originally, the symptoms had the value of yes and no, but then it turned to be 1 to 0, which is 1 present yes and no present 0. Further activity in this stage involved data reduction phase, where the number of attributes were reduced as well as the number of records, leading to balance skewed data. Again, upon completing the data reduction process, we consulted the medical expert to seek for their opinion before proceeding the further tasks. Next, selection and implementation of data mining experiment. In this phase, data mining technique and algorithm used in this project are predictive technique and decision tree. I used Waikato Environment for Knowledge Analysis, WICA. Tool for do the data mining. And lastly, after I've done a few experiments, I decided to implement LMT, Logistic Model Tree, and J48 with implemented C4.5 decision tree to generate roles. 6 experiments had been executed. Both decision tree gave the cross-validation equal to 10, with percentage split 66% and 60%. I will show you the data at the next slide. And lastly is result validation and impact analysis. In this phase, we have 2 things that have been carried out. First is validation of rules with the medical expert. All the generated rules from LMT and J48 were validated by the medical expert. And lastly, the dashboard of the mobile application had been published. So this is the simplest process this is the simplest form on how the process had been carried out. First, data selection and preparation consists of 296 patients record had been uh, at this stage, it had be in data transform and had been adjust and adjust. So use next step is do the data mining process using Reka. Then it will turn to rules evaluation and transformation. This is how the rules came out. And lastly, the mobile application had been developed. So this is the part of the rules generated, and this is the part from the experiment had been carried out for the 6th time. So this is the part of the rules generated from the both LMT and from J48. This is the result. As we can see, if gender is equal to female and vomiting, bloating, and lost appetite, she might have acute gastritis. So same goes here. If bloating, then acute gastritis. You can see the similarity here. Bloating, acute gastritis. So the accuracy table, as for LMT, cross validation equal to 10 is 61.14, 8.6. LMT with percentage split 66% is 61.3861%. Percentage split equal to 60% is 61.0169%. Next, for J48 decision J48 it's 48.9865%, 45%, 44.9153%. So this is how the smart self-checkup disease diagnosis mobile application. This is the dashboard, the home page. Next, this is the symptoms page where the user can click the gender and can choose the symptoms that they feel, and lastly the results will show what the user feel might have. So this is the video. So that's all. Thank you.